This video is an overview of chemical bonding. We are going to talk about 4 kinds of bonding: ionic, covalent, metallic, and network covalent. Let's start with ionic. Now, I'm sure you'll recall from last year, ionic is between a metal and a nonmetal. We have metals that are positively charged. We have nonmetals that are negatively charged. What's causing the bonding here is an electrostatic attraction, i.e. the positives and the negatives attract each other, and that's what forms a bond. Remember, when we're talking about a formula, we always say lowest ratio, but in reality, it's a whole bunch of ions of positives, say, surrounded by negative ions in a widening crystal lattice, that's called. Second type of bonding, covalent. Covalent is a nonmetal bonded to a nonmetal. The simplest kind, the kind we talk about in your first year of chemistry, is binary. That is 2 different elements bonded together. All the ones you draw Lewis dots of, for the most part, are covalent binary things, nonmetal to nonmetal. This is no positives and negatives here, no ions here. This is the sharing of electrons. And of course, those electrons can be shared equally or unequally, polar, nonpolar. Topic for another video. Right now we're just talking covalent, metal, nonmetal, sharing of electrons. Metallic is what happens in a metal, a pure metal. The key phrase here is sea of electrons. What that means is you have a whole bunch of nuclei, and each of these nuclei have electrons around them, but the electrons kind of don't stay with their own nucleus. They kind of move around among the nuclei, just like children in a neighborhood going from house to house to house to house, where everybody's parents looking out of everybody and nobody's really caring whose kid is whose. That's what this means, okay? There's just free moving electrons. And last but not least, we have what's called network covalent. What that means is you have a whole bunch of covalent bonds all strung together identically. The 2 examples are usually diamond and silicon dioxide or quartz. Also graphite, at least part of graphite. Graphite is network covalent in basically layers and then weakly bonded between the layers. So, let's talk characteristics. Network covalent compounds are very, very strong. Diamond's one of the hardest substances known, because it is this 3D network of bonds. Very, very strong. Metallic, sea of electrons. The big thing about metallic things is they conduct electricity. They conduct heat, because that sea of electrons moves. The moving charges is what conducts electricity. Metals have very high boiling points, high melting points. That's why they're solids when you see them, and they are conductive. Covalent compounds, electrons are being shared. There are no charges here. No conductivity here. When I'm talking about covalent compounds, I'm talking about individual molecules. Unlike the crystal lattice of the ionic, covalent are individual molecules. So, again, this idea of intermolecular bonding, bonding between molecules, is for another video. But if you think about something like CO2, there's CO2. These bonds, if I'm turning CO2 from a solid to a gas, you remember CO2 doesn't actually go to a liquid in between, the bonds that are breaking are the intermolecular ones, the ones between molecules, not the covalent bonds themselves. And the bonds between molecules are fairly weak. So covalent things, low melting and boiling points. Okay. But on the other hand, there are no charges here. There's no moving charges, no conducting. Ionic things, we've got charges. In order to conduct electricity, the charges have to be moving. So a solid, as I have already said a couple of times, a solid is in this crystal lattice. They cannot move. There's no conducting of electricity when they are solid. But stick it in a solvent, like water. Now the positives and the negatives are separated from each other and surrounded by the polar water molecules. Now the charges can move, and now there is conducting of electricity. On the other hand, there are none of these weak intermolecular bonds, so these guys are higher melting and boiling points. Oh, and while I'm talking about this, let's talk about solubility. Ionic things dissolve in ionic solutions. I know water is not ionic, but it's very, very polar. So again, it's this idea that in order for this guy to separate into separated charges here, the charges have to be surrounded by something that stabilizes them. So you have to have a really polar solution like water to dissolve ionic things. Whereas covalent things, there's no motivation to separate them by a polar thing because there's no charges to be neutralized. So it's nonpolar solvents that will dissolve covalent things. Things like hexane, which is a nonpolar compound. Metals do not dissolve. Network covalent do not dissolve. They're too stable to do it. Okay, so that's an overview of bonding.